So say you've been building your model for a while and you want to see what you have so far. So you click on that view button on the left to get an overview. So this is the entire model so far, all of the nodes that all of the builders have contributed. And it's a bit of a mess, and that's understandable because you are modeling a complex system. And if it weren't full of interconnections and entanglements, then you'd be suspicious. Why are you even modeling it in the first place? The first thing that you should remember is that in the Elephant Builder, all of the graph diagrams are zoomable. You can zoom in, zoom out, you can drag the whole model around. To zoom, I'm using a scroll function. You can use a scroll wheel on a mouse. I'm using a two-finger gesture on my trackpad. If you're using a device that allows pinch gestures, then you can pinch in and pinch out to zoom in and out. The other thing to remember is that you can, you can drag individual nodes. So if you have nodes that are overlapping or just crowding the model, then you can tidy things up that way. Over here, the buttons in the right-hand pane, there's a full screen function that allows you to fill the entire computer screen with your diagram. This is especially nice if you're projecting onto a wall for a group of builders. There's a matrix view that just lists all the nodes and columns and rows, and the intersection, the cells, are how these row nodes influence these column nodes. S's denote same direction influences. O's are for opposite direction influences, and the number of clock icons are for the delay that you enter when you create a new connection. There's a stats view. When you first open it, it lists all the nodes alphabetically, but you can resort these so that if I click out degree centrality, then I get the nodes in decreasing order of how many outward going connections I have, or how many inward going connections I have, or how many connections at all do they have, or how many connections do they have to other nodes, where the algorithm takes into account how important those nodes are based on how they're connected to other nodes. So this eigenvector centrality uses an algorithm that's similar to what Google uses for its page rank. I can get a close-up of any node. I can look at what we call the causal neighborhood. So if I choose a particular node, then it shows me, here's the node that I chose, food safety. It shows me the causal neighborhood. In this case, it's the 3-step neighborhood. Every node on this map is within 3 steps of food safety. I can go down to 1 step and see just what are the direct connections, or I can go up to 5 steps. It takes a few seconds. So everything here is within 5 steps of food safety. Here it is, food safety. This is the circle view. This is nice because it looks cool, but also it lists all the nodes in by order of how many connections they have. So at the noon of the circle, the top of the circle, is the node that has the most connections. In this case, it's electricity reliability, I saw. And as we move from noon toward 1 o'clock, 2 o'clock, we move to nodes with fewer and fewer connections. If you want to be able to scan through the nodes alphabetically, because there's a particular node that you're looking for, this grid view lists the nodes alphabetically, and you can still see from the density of lines which ones are more connected and what are they connected to. This spread out view is the default. It's the first view that you see when you click view. And this just tries to arrange everything so that everything is as spread out as possible. It uses a spring simulation to try to simulate what would happen if all these lines were springs and everything were spread out. And this concentric view lets me choose a node and place it in the middle of the screen. And it creates sort of these concentric circles of nodes around it. So as I move outward from the middle, I get nodes that are further and further causally removed from that, in this case, from gasoline supply. Okay, so these are the visualization features of the Elephant Builder. These are the features that allow you to try to make sense of a complicated model using your eyes and the pattern finding features of your brain. But the beauty of the Elephant Builder is that it has analytical features, because our brains are often not enough to make sense of the complex models that we model. So in other videos, we'll be looking at some of these analytical features, but these are the ones that help us augment our eyes and our brain.